Hello, my name is Olivia.
I'm Jacqueline.
And I'm Emily.
And we are circling back around to biotoxicity. So you've probably already heard a little bit about it, but biotoxicity is essentially the buildup of toxins in an organic body, and we analyzed how silver affects yeast as a biotoxin. We used yeast as our model organism, and yeast, one cool thing about yeast is it has a cellular respiration process where it takes in glucose and oxygen, and it emits carbon dioxide and water. So for our experiment, we used silver to kill yeast cells. We used 3 different forms of silver. And we measured their effectiveness by how much CO2 output there was using a manometer or a gas measurer. So we used 3 different types of silver. We used nanoparticles, silver powder, and Ag+ ions, which we took from silver nitrate solution. So the powder was too big, so it didn't kill the yeast cells. The Ag+ ions could effectively pass through the ion transports in the membrane, but it was a really slow process since the silver ions are positively charged. And then when we did the nanoparticles, we found that they were around the same size as glucose molecules. So what happened was the yeast cells were kind of tricked into thinking that these nanoparticles were glucose. So the yeast cells kind of wanted these nanoparticles to come in, and what happened was the Ag reacted with the lipids in the cell membrane and broke down the membrane, effectively killing the cell. So that was the most effective in killing the yeast.
All right. So in the drawing, you can see 3 different animals, and they are their objection is to try to enter the building and kill all the humans in the building. So the giraffe kind of had some trouble getting into the building because he's too tall to enter through the door. And then the snails, they were able to get into the building, but they were too slow to catch up with the humans effectively enough to kill them all, because some humans were able to get away. And then in the final illustration, you can see that there are bunnies who seem very nice and sweet and cute. And so they're able to get in because they're able to disguise themselves as cute little bunnies. They're bunnies, but they're not cute. So when they get into the building, they turn evil and kill all the humans.
All right, so I'm just going to elaborate on that. I'm going to show you how the drawing is a really good representation of the concepts. So first, I'm going to talk about the gate, which says entrance and the humans inside. So the gate represents, the entrance right here represents the cell membrane, and inside are kind of like the yeast cells that we're trying to kill in our lab. And then all 3 different kind of animals with the 3 different kinds of silver that we used. So going one by one, the giraffe right over here was a representation of the silver powder. The snails were a representation of the silver nitrate, and the bunnies were the silver nanoparticles. So as Jacqueline said before, the giraffe had problems getting in because it was too big. And this is a really good representation because the silver powder, although it also can break off in ions, but because the powder is too big, it can't penetrate the cell membrane. So going to the snails, as you can see, the snails are able to get in and kill the humans, but as you can see, the snails are really slow animals. So although they work, they're very slow and not as effective as, let's say, bunnies. And I thought it was really clever that the illustrator had the snails saying words that are like, oh, be positive, we can do it. So they're saying really positive things to represent how the ion had a positive charge. So I thought that was a really clever way to represent that. And then in our last picture right here, the bunnies, they represent what Jacqueline was saying. It's they look super sweet until they get inside, and then they look kind of demonic and kill the humans. So it's kind of like a Trojan horse kind of thing where it looks it's a gift from the outside, but once it enters the actual cell, it becomes the downfall. So I also want to talk about how the artist did a really good job showing how using the animal size, although the snail is smaller than the bunny does a better job getting inside because it doesn't have a charge. That's why it's not saying anything, and the snails are saying positive things. So does anyone have any questions? Thank you.
Just a theme that I'm catching up. I'm curious, should I be led to believe that speed is always better?
In this case, like, because it's a lot slower because the ions have to go through, if they're going to penetrate the cell membrane, they have to go through the ion transport channels. So it's a little bit slower, so it's not as effective. So the silver nanoparticles are able to kill the cells faster and it's more effective.
If you have the same effect at the end, if all the people are killed at the end, given the illustration, is faster always better? I'm not convinced. Maybe it's not your job to convince me.
Well, I mean, we were really looking at effectiveness in killing the yeast cells here. Like, yeah, the snails kill the yeast, but if you have a set time, then the nanoparticles are going to be a lot faster in killing the yeast cells.
My hint to you is, while the giraffes and the snails and the rabbits are having a party, what are the yeast cells doing?
Yeah, as like if you allow them to grow because it's really slow, even more yeast cells will appear and it's gonna make like, let's say like the disease even worse or something. So time is kind of the essence here. Yeah. Thank you.
So why are the instructors teaching you how to kill cells?
So like one of the real life applications to this would be like we had a lecture about how this was used in medicine today. So let's say like tumor cells from cancer. It's super like right now the ways we have to kill them are really ineffective because they also kill the good cells in the process of doing that. So as we use like nanoscale, like nanoparticles to do this, we're able to target them a lot better. And yeah.
In this experiment, it's very size selective, and so the application you talked about does have some targeting concept. Just without any of the targeting concept, what would be the size selection by itself as solution for a real application? So this one, the experiment you didn't depend on targeting. As tumor cell versus a normal cell. It just tells you to kill cells.
Yeah.
So they all kill cells and effectively or non-effectively. What would be an application such that this would be sufficient?
Where might you use this in a lower tech application than differentiating cancer and regular cells? Where would you actually use this?
Yeah, just
Antibacterial.
antibiotics. You could just use it in medication to kill like viruses in the body.
We also know that the cells are just cells, right? We are made of cells. Why would we want to eat something that would kill cells?
I mean, I would say even just in like antibacterial wipes, or where you're trying to clean something that's organic off of something that's non-organic.
To worry about killing the normal cells if you're just using like let's say wipes because the objective would be to kill like the bad things, but if it was used in medicines, like I think the in the lecture they told us how like normally these like nanoparticles they have like a target on them to make sure they kill like at the minimum amount of healthy cells as possible.
But so your parents don't worry, is the silver nanoparticles you made harmful to you?
Yeah, at large doses it can be, but if you like consume a small amount.
You could drink them, but don't.
Yeah.
But you can't. Why?
It would start.
If you drink them,
It would start to kill off your cells.
you turn blue, but
Oh. Okay.
So I guess to make sure that our parents are comfortable that we're teaching you guys how to kill things that will affect cells, what is the reason why, say, human cells are not affected as much as the cells that you want to kill, like yeast and germs and bacteria? What is the difference between human cells and these bad cells? Maybe it's too long. I think we have another one.
we do have one more. Okay, we're going to leave for the last group. Where's the last group who's doing this? Somehow you need to work in there.
Because we'll make sure your parents
Wait, does your body have like vitamins that break down the silver particles so it's not as toxic?
Are they? Okay.